Hello student, today we are going to learn all the concept from angular momentum. Okay, the first thing we are going to learn in angular momentum is equal to linear momentum times of radius. Okay, the next one, SI unit of angular momentum. The next one, dimensional formula. Okay, then we are going to learn the relation of torque is equal to I alpha. This equation we are going to learn how to derive. Okay, the next one, it is L is equal to I omega. Angular momentum is equal to I omega. Okay, the next one, dl by dt is equal to torque. This relation also we are going to learn. Finally, conservation of angular momentum. Conservation of angular momentum. Conservation of L also, we can say L, we can take it as an angular momentum. Okay, when angular momentum will get conserved, dl by dt is equal to 0. When we are getting like this, we can say this is going to be conserved. Okay, yeah, when we are getting this kind of equation, that's the time L is going to become as a constant. Don't take it L as a 0. Okay, now we are going to learn these are the concepts. Okay, I will start from beginning. First, angular momentum. What is angular momentum? Angular momentum is a product of, it's a linear momentum and radius. Product of linear momentum and radius. Okay. Now, SI unit. What is SI unit of angular momentum? Momentum is equal to mass into velocity. So, mv, momentum is mass into velocity, mvr. Okay, momentum is equal to mass into velocity. So, mass is kg, unit, velocity is displacement by time. So, meter per second. Radius, we can take it as a meter. Meter we can write as a meter square. So, kg, meter square. From denominator, second if you are taken as numerator, second minus 1. Okay, this is the final SI unit of angular momentum. What about the dimensional formula? Dimensional formula is equal to, for mass m, length is L, time is t. Okay, length is square time is minus 1. Okay, now we learned so this two. Okay, this three we learned. Now I am going to prove torque is equal to I alpha. So next thing we are going to see, torque is equal to I alpha. So what is torque? Torque is equal to force into perpendicular distance. Force into perpendicular distance. So force is equal to mass into acceleration. So mass into acceleration, perpendicular distance, we can take it as a radius. Okay. Now I am going to teach you another relation also because it's required. Okay. In circular motion, radius we can take it as a r. Angular displacement we can take it as theta. Arc length we can take it as a s. If you want angle theta, you can take it. You can divide arc length by radius, s by r. Okay, this is a relation. For full complete circle, displacement is going to be 2 pi r divided by r. It's going to be 360 degree. Okay, that means this equation is correct only. So theta is equal to s by r. So theta is equal to s by r. What is s? S is equal to theta times of r. Just I am differentiating this equation. ds by dt, d theta by dt into, this is r, radius. So it is going to be v, this is going to be omega, and this is going to be r. Displacement by time velocity, angular displacement by time angular velocity. Again, if you are differentiating dv by dt into d omega by dt into r, again I am differentiating. See what I am going to get? Velocity by time acceleration, angular velocity by time angular acceleration. So a is equal to alpha times of r. Okay, like this we can get. So this is a relation between linear motion and rotation motion. This also I am going to use. So here I got a torque. I have a is equal to alpha times of r. Just you can substitute here. So torque is equal to m alpha times of r into r radius square, mr square. So torque is equal to mr square alpha. What is mr square? We can call inertia. So inertia is equal to mr square. So it's going to be alpha, torque is equal to I alpha. So we proved the next thing also, torque is equal to I alpha. Okay, next. What is the next? L is equal to I omega. Angular momentum is equal to I omega. That's we are going to prove. So the thing is L, angular momentum is equal to linear momentum times of radius. What is linear momentum? Mass into velocity into r. V is equal to omega r. Already I told you. So if you are substituting this here, L is equal to m omega r into r. So mr square omega is equal to L. So what is L? This is going to be inertia times of omega. This is an angular momentum I got. Okay, what is next? So differentiation of angular momentum will get torque is equal to angular momentum is equal to differentiation of with respect to time is equal to torque. So you can take it any equation. See here, I am taken torque. I am taken this equation. L is equal to I omega. If you are differentiating this, dl by dt is equal to I d omega by dt. Angular velocity by time, we can take it alpha, angular acceleration. So dl by dt is equal to I alpha. What is I alpha? I alpha we can take it as a torque. I alpha we know already torque. I alpha we know already torque. So dl by dt is equal to torque. Okay, now I got like this. Okay, the next one, conservation of angular momentum. Whenever angular momentum is become 0, dl by dt is become 0, that time we can take it as a conservation of momentum. When dl by dt will become 0? When the torque is 0, when torque is 0, dl by dt is become as a 0. Okay, this is a time when the external torque is 0, automatically the angular momentum will become as a constant. Okay, don't take it L as 0. L is going to become as a constant or conserve. Okay, thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.